Shalom to you and welcome. In this video, we'll look at what congruent figures really are. What are congruent figures? And how can we tell and we're going to determine what congruent figures are and accurately identify the corresponding parts of congruent figures. So you look at this figure here, which I did in GeoGebra. You can see that this triangle is the exact same triangle that has been rotated all around a certain angle. So these triangles are congruent. They are congruent because they're exact same. So congruent triangles are figures that they have the same size and shape. So two geometric figures are congruent if one of them can be placed on top of the other and it would fit exactly point for point, side for side, angle for angle. Okay, it will just overlap each other. So we use this symbol. That may be a new symbol for you, which means implies. We have done if-then statements. So these are how we do implies, which means if blank, then blank. If the arrow is double both ways, it means both sides of the statement can be switched, they can be reversed. Congruent polygons implies that all pairs of corresponding parts are congruent. Likewise, all pairs of corresponding parts are congruent implies that it's a congruent polygon. Every triangle has 6 parts, 3 angles and 3 sides. So each one of those angles has to have and this corresponding side has to be congruent, and each part of the segments, the sides, has to be corresponding. So if you have, sometimes you look at the order, even without the picture, like here you have triangle ABC is congruent to triangle FET. So angle A must be congruent to angle F. Angle B must be congruent to angle E. Angle C must be congruent to angle T. It has to go in that order. Likewise, segment AB has to be congruent to segment FE, and segment BC has to be congruent to segment ET, and segment AC has to be congruent to segment FT, and so forth. Okay. Now let's look at this picture. There are 3 ways we call transformation. Just like we said, congruent figures are the same, exact same figure that has undergone transformation. The 3 transformation that does not change the size or shape would be translation if it is slides, and or rotation if it has turned at certain angle like the one I showed you before, or if it has been reflected over a line or point. So let's do this as an example. If we have these triangle ABC, if it's named triangle ABC, you have to match the angle A with, it has 3 symbols, so we're going to match with D. So it's going to be congruent to triangle D, and then B has that one single, it's going to match with E, DE, and then F. So that's the only way you can name them. You can't switch the points, the angles. Likewise, segment DF, so DF is over here. DF has 3 marks, so it's going to be this 3 AC. But you want to make sure you check to see that the angle D matches with angle A, the way you name it. So DF is going to be segment AC. So how about by here? Watch for, the sliding translation is kind of easy to identify because it looks exact same. But rotation is where you have to be careful because things has been switched. So it's in triangle TIR. Again, we look at where angle T is. Angle T is over here, and angle T has 2 marks. So we look for a letter that has 2 marks. Angle has 2 marks is B. So it's going to be triangle. I'm going to write it over here, B. And then I we look for I has only one mark, angle I. So which one has one mark here is A. So we're going to match it with A, and then C. Okay, segment AC. Segment AC has one mark. It's going to be this segment here that has one mark. It's RI or IR, but you have to be careful which one. How do we write it? The order matters. If A comes first, A is with this angle that is single, then it has to start with I. I is the one that has single. So it's going to be IR. Okay. Now, come to reflection. This has been reflected over line segment AC. So you see exact same triangle, identical. So see the triangle CAB. So it's CAB. So you see there, the two triangles, they share this line. So C is going to still be C. So it's going to be, oops, I'm going to write triangle. Sorry about this. It's going to be triangle C. So we're going to go to A also. CA. And then D. Okay, because CA is CA, it's the same segment. CA is same segment, CA for both of them. And then segment DC has two marks here. It's going to be BC or CB, but again, which angle matches with D? Over here, D will be B. So it's going to be BC. And CA, yes, CA. So CA is going to be CA. It's going to be congruent to itself. And we call this reflexive property because it's the line of reflection. It's a reflexive property. And we'll define it in the next slide. So a line or an angle, a segment or an angle is congruent to itself. That is a reflexive property. So you'll be needing that in a proof. Any angle or any segment is congruent to itself because it doesn't change. So here we have that reflexive line. AC is congruent to AC. So here we have a reflexive angle. So look at this. There are two triangles here. You have this. Let me draw this in red. I have that triangle here. And it has that BA in it as the smaller side. But we also have, I'll draw this one in blue. We also have this triangle here in blue, overlap. And so this is the same triangle. It has been rotated. Somehow it's rotated. And so the small side shifted over here, the longer side. But those two triangles are congruent. And angle A, both of them share angle A. Angle A is congruent to itself, is reflexive. So angle A is congruent to angle A. That's the reflexive. Here we have already said that segment AC is congruent to segment AC. So that's reflexive property inside and then angle, how you see it. Okay, so I hope you understand this and you can do your homework.